Welcome all. In this video we are going to cover what are codes, standards, specifications, major differences and advantages. So let us see how we are going to break this topic into subtopics. First of all, we are going to look into what is code, the basic definitions, few important facts, and along with that we'll look into important ASME pressure piping codes. Then in the end there is a link for a quiz also, which you can go and you can attempt the quiz. Then we'll look into what are piping standards, what type of piping standards are there, and we'll look into further detail for each and every type. Then again there is a link for the quiz, you can attempt that quiz also. Then we'll look into what are piping specifications, few important facts. There is again a specific quiz link for this section. Then we'll look into few examples. Then we'll look into what are recommended practices, especially for piping engineering field, and we'll look into few examples also. Then in the end we'll see what are the basic differences between codes and standards and what are the advantages of having such codes and standards. So at last there is a link for video, and there will be a link for a piping quiz also, that is specially related to codes and standard. So let us start with what is code. Piping codes are defined as the requirement of design, fabrication, use of material, tests and inspection of pipes and piping system. Now if you look at the basic definition, we are talking about the requirements of design. We are talking about requirements of fabrication, what kind of materials we are going to use, what kind of test and inspections will be there. So this is basic system. We are talking about all the piping systems, right? And this is what is required. How we are going to design, how we are going to fabricate, how we are going to manufacture it, how we are going to test whether this manufacturing, fabrication and everything is in line with the requirements or not. So that means these codes are giving us the basic requirements, right, which are globally accepted. So this is just a basic definition. Let us look at few important facts so that we can further understand what are these codes. Codes define what you need to do. Okay, suppose you want to set up a refinery, then what do you need to do, right? For any process plant, whatever are the requirements, those are defined by the codes. Code has a limited jurisdiction defined by the code. Code is not a law but can be adopted into law. So these two statements are very critical, which make it different from standard, specification and any other specification. There may be few committees which once they adopt these code, then it becomes a law. Okay, then the usage of that code is legally required. So that is major difference. This is not there for any standard, any specification. Only this is, if it is there, then it is there for codes only. So codes provide the specific design criteria, right? We discussed here also all these design requirements, all these design criteria will be defined in this. So what kind of material, MOCs, how we are going to select the MOC, what will be the allowables, what kind of materials are available in the market. So these will be defined here in detail, right? How we are going to select the allowables, loading criterias, right? Pipe wall thickness, material behavior, how it will be behaving with respect to internal and external pressure, design rules for non-standard fittings like miter bands, for reinforcement pads. So these are the basic things which are there in the code, and they fulfill the requirements of design, fabrication, use of material, everything will be defined in the code. So this is basically a major definition of the code, you can say. Now if you see, we have a lot of ASME pressure piping codes with us. So you can take it as an example also, so that we can understand what we were discussing in this section, and it will relate it with the definition also. This basic definition will remain the same. We are going to get the requirements for design, material, fabrication, inspection and all. So there are so many other codes specifically for process industry. So let us see what kind of codes are there. If you talk about ASME 31 series, right, it is series of piping codes. So it can be 31.1, it can be 31.2, 31.3. So these kind of codes are there. Okay, if you look at its history, this was started in March 26, 1926, right? Then the first edition was published in 1935. So there are group of professionals, group of industry experts who keep on developing these things. Since December 78, the American National Standard Committee B31 was reorganized as ASME code for pressure piping B31 committee. So this committee was built in 1978 and these codes were developed later on. These codes are commonly used for design of commercial, power and industrial piping, right? In industrial piping, there will be a lot of piping systems, which we are going to see here. For example, for power, we are using B31.1, right? This is a code for power piping. Then fuel gas piping. This was there, but now this is not there. Now it has been withdrawn, right? But 31.2 is still available from ASME and is good reference for design of gas piping. Although this code is not there now, it is withdrawn, but still, if you want to refer few clauses related to fuel gas piping, this code is good. This is available from ASME side. Then process piping for all the petrochemical refineries, chemical, pharmaceutical, textile, right? All these process segments will be designed based on ASME 31.3. This is for process piping. Then pipeline transportation for liquids. Then there is a 31.4. Piping transporting products between plants and terminals. Okay, so this is used for transporting the products between plants and terminals. Again, refrigeration piping, there is 31.5. Gas transportation and distribution piping system. If you want to design piping system for transporting or distributing the gas, then we have to refer 31.8. For building services piping, we have to use 31.9. For slurry transportation, standard for hydrogen and piping. So these are the codes which are available with us to design our systems. Not only for design, all the requirements for design, fabrication, use of material, test, inspection of pipes and piping system. So if anybody asks you what is the purpose of code, we can always say this gives us the requirement to design, fabricate, use of material, test, inspection of pipe and piping its systems. This is the basic definition, and we have different codes for different type of piping which is already there with us. So here there is a link, you can look into this and you can start your quiz also if you want. Then let us see what are piping standards. We know what are piping codes now. Now let us look at what are piping standards. Standards provide specific design criteria. Okay, there we were looking into the requirements. Now we are talking about design criteria and rules for individual components. So each and every word of this statement is important. It will define the definition and also it will differentiate the piping standards from piping codes. So we are going to get the design criteria, rules for individual component, right? So how it is different from code? Let us see. Here it is giving us the requirements, right? If you want to do something, it will tell us what you need to do, right? In piping standard, it is telling us how to do it, right? So this is a basic difference. There are so many types of standards. For example, dimensional standards are there, pressure integrity standards are there. You can say the material standards, right? The design standards. So these are few of the categories which are available under standards. If you look at the dimensional standard, this is very commonly used standards which are, I'm sure most of us are already aware of this thing. But let us see what are the definition, what dimensional standards are, and what purpose they are fulfilling. Right? They, first of all, these are the standard which establishes the benchmarking of configuration, the dimensions, parameters of any piping components. Okay, so name itself is indicating it is talking about the dimension of any piping component. So it establishes the benchmarking. How it is establishing? If somebody says we are going to design a T, a flange, right? These standards will define the dimensions of each component, so that everybody globally knows these are the dimensions. If somebody is asking for 4-inch flange, 150 pound rating, they will refer to these standards, and they will come to know what dimensions they have to manufacture, right? So it is giving us the standardized things. Then purpose of these dimensions, the main purpose is to ensure and establishing that similar piping components are manufactured. Okay, so everybody knows if this standard is saying this much is the dimension, they have to manufacture that way, and same way the connecting or associated items will be designed. So it establishes the standard. Now let us look at a very interesting fact about dimensional standards. If we are saying that any manufacturer has confirmed that they are following the dimensional standard, then can we say that if the same item is manufactured by two manufacturers, the performance will be same? Okay, so this is very interesting. Although we are saying there are two manufacturers and they are manufacturing two valves, okay, each manufacturer is manufacturing a valve 10-inch and 300 pound rating, and they are using the same dimensional standard. Can we say the valves from both the manufacturer will perform similarly, in a similar way? The answer is no, because there are many other aspects also. The valves would be physically interchangeable between 300 pound flanges in a particular system, no doubt, because dimensions are matching, pound rating is matching, bolt circle will be matching, bolt dia will be matching, but at the same time the performance of these two valves may be different. Reason is there may be many other items which are associated with the valves, right? For example, there can be a different seat, disc design may be different, one valve might be capable of meeting more stringent requirement and seat leakage criteria than the other. So although these two manufacturers are referring to the same dimensional standards, but still the performance of these two valves can be different. Now there are so many dimensional standards which are already available with us. ASME B21.1, these standards are related to pipe threads, general purpose, right, dry seal pipe threads, face to face dimensions of valves, metallic gasket, non-metallic gasket, butt welding ends. Okay, this is very common, 36.10 and 36.19. 36.10 is for dimensional standard for welded pipe, carbon steel pipes, and this is for stainless steel pipes. So you can say these standards which are commonly used as a dimensional standard are available with us, and they are setting up the benchmarking for standardizing the dimensions. We are not saying the performance, only the dimensions, right? So again there is a link for quiz. You can always click over this, and this will be this quiz will start, and you will get 10 minutes to complete this quiz. Now there is a second category, that is pressure integrity standards. First of all, let us try to understand what is pressure integrity. Then only we'll look into what are these standards. This can be defined as the structural and leak resistance capability. This is the key word here. Structure and leak resistance capability of product to contain applied pressure. Okay, we are saying if we are applying a pressure, so we in the end we are talking about the pressurized piping, right? Pressure piping we are talking about, so there will be pressure. So once we are preparing a item, a component, we are manufacturing a component, it has to be leak resist, it has to have some leak resistance capability. So that capability is called pressure integrity. Now what are the standards with us which are setting up the benchmarking for pressure integrity? So those standards are called pressure integrity standards. right? So which provides maximum pressure holding capacity of that particular component. These rating based components will be there, which will be defined in these standards, right? So there is another interesting fact, as we discussed here for dimensional standard, that although if two manufacturers follow the same dimensional standard, still the performance we cannot guarantee that will be same. Now in case of pressure integrity, the scenario is different. All components which are designed and manufactured to the same pressure integrity will function in equivalent manner, right? Which was not the case in dimensional standard. So this is interesting. Now let us take an example to understand the same. If we consider a flange of 12 inch which was constructed in accordance with the ASME 16.5. 16.5 is one of the pressure integrity standard, right? If suppose two manufacturer, they manufacture two flanges, each 12 inch 150 pound rating, and they follow the pressure integrity standard, that is 16.5, then we can always say the pressure integrity standard is followed, the performance of these two flanges will be same. This is the major difference between pressure integrity standards and dimensional standards. Now let us look at a few of the pressure integrity standards. If you see 16.5, which we were talking now, it is there in the list, and it is one of the pressure integrity standard. 16.34, this is also again related to valves, right? We design valves especially for pressure rating. So all the pressure rating details related to valves will be there in the 16.34. A lot of dimensional requirements will also be fulfilled by these standards, but somehow we call it pressure integrity standard. So this is the list of all the pressure integrity standard which is commonly used in process industry. Now again, let us talk about the third part. What are piping specifications, right? This is again sometimes we confuse it with the piping standard, piping code. The specifications are something different. Okay, if we are working in any of the project, in the beginning we have to prepare many specifications which will be used throughout the project, throughout the life cycle of the project, right? So those documents which we prepare at the initial stage of the project are defined as piping specification. Sometimes we call it a piping spec also, right? It provides appropriate selection, specification and material grade of the pipe. For example, if we are talking about PMS, right, then you can easily understand this definition. PMS is one of the specification which is developed during the initial phase of the project, and it covers the appropriate selection, how we are going to select the material, what are the material grades, what are the various piping components in a particular project. So it will be defined in that particular specification, right? Then it also give us the guideline or instruction how we are going to maintain it, how we are going to repair any particular section of the pipe, right? So those kind of documents which are prepared are called specifications. Piping specifications become basis and act as the key to correct material selection. So this, once we develop it, this will become the basis. For example, design basis is there, support standard is there, right? So these are few of the examples. If you look at here, we have listed out design basis is one of the piping specification, which is again giving us the basis to design our plot plan, equipment layout, selection of material. So all these bases will be given in the design basis. So this is one of the specification which is developed during the initial phase of the project. Then PMS is there again, which we have already discussed. Selection, specification, material grades, everything will be defined in this specification. Support standard, here again type of supports, what kind of material will be there, loading, spacing criteria, everything will be defined in that particular specification. Then valve material specification. VMS is really very important document which talks about various valves which are there in the project, along with the complete process detail, performance detail, like all parameters will be there in the form of process valve data sheets. So again, this is very important specification. Specification of material requisition, all the MRs which we prepare in the beginning so that we can communicate with the vendors, what kind of requirements are there in the projects, and vendors can also understand what we are looking for, right? So all these requirements are listed in these specifications which are prepared at the initial stage of the project, that is design phase of any project, right? Then only we can plan our project and we can execute a few of the activities. Then again, there we talked about codes, we talked about standards, right? Here we talked about code, we standards we covered. Then there is piping specifications. Now let us talk about what are recommended practices. If you click over this, we'll go to that section. Now let us see what kind of recommended practices are there which are very useful, which are available in process industry. Recommended practices can be available from two sources. First of all, there are two sources which are available with us from where we can get these recommended practices. First of all, these practices may be prepared by some professional groups, right? Now recommendations are there, best practices are there, lessons learned are there. So based on these things, based on past experience, based on mistakes which were done in the past, lesson learned, all these things will be there in you can say the project's database. There will be a lot of professionals who were working in the past on similar project. They made few mistakes, right? But still they executed that project. So those learnings from these professional groups will be listed out so that same mistake is not replicated in the projects. So these are the professional groups which keep on collecting such experiences into, and they document it and they call it as a best practices. For example, Shell and Ramco standard, which are very popular, and they are globally accepted as the best practices and adopted in many other projects by other clients also, right? Then second category is prepared by company itself. In any company, for example, if you talk about any EPC company or any client company, they keep on developing their own specifications. For example, there will be a quality management system, so that they keep on capturing all the technical requirements which they think will be typically used in many of the other projects, right? So these requirements will be captured, and the same can be used when we are executing the project. Then the same best practices can be used to audit the ongoing activities. So this is how these companies prepare, so that they can use these best practices to develop these specifications at the design phase. Same can be utilized to audit how whether we are fulfilling the technical requirements or not as per the past experience. So this is about recommended practices. These can be prepared by professional groups who have learned from their past experience, and by companies also. Then what are the differences between codes and standard? Now we talked about codes, we talked about standards, we talked about specifications, we talked about recommended practices, we to look into various examples. Now we have basic idea. Let us see what are the various basic differences between codes and standards. If you look at these codes, they always explain the rules, what you need to do, right? Standards tell us how to do, and specifications establishes the requirement of the company. So this is the basic difference: what to do, how to do, and execution. Code is a group of general rules or systematic procedure for design, fabrication, installation, inspection, and are adopted by legal jurisdiction, which we talked in the beginning. If it is adopted by the committee, and then it becomes law. This is a basic difference, which is not the case in case of standards or specifications. So this is also one of the major difference. Here we talked about rules, what to do, how to do, and establishes the requirement. Here we are talking about this can be adopted as a law also. Then code has the force of law, unlike standard, which we discussed in the second point also, which are voluntarily accepted guidelines, which becomes mandatory only when incorporated into the business contract. Okay, it becomes mandatory only if we add it into the business contract. So this is major difference between code, standard, specification, best practices. Now, why we are discussing all these? Why we need these codes and standards? right? We discussed a lot of things about it, but let us summarize in the form of advantages of having codes and standard. First of all, let us see codes and standard using consistency, bring consistency. If there are 100 clients and they use codes and standard, then everybody will be using the same kind of dimensions, same kind of rules, same kind of safety aspects, same kind of inspection criteria. So this will bring the consistency globally to the technical standards. So all the technical specification standards will be developed based on these requirements, these rules. So the consistency will be there. This is a major benefit. So everybody will be talking in a same manner. Helps using standard working. So once we have consistency, we will be working in a standard way. So we know how the other clients are working, what they are thinking, how they are implementing the safety aspects. So similarly, we can establish in our own projects. Working with codes and standard ensure built-in security, reliability, and continuity. Right? Built-in security means there will be factor of safeties in so many codes and standards. So that if we keep on following those standards, this built-in security will be implemented in our project also. Right? Once this is implemented, we can say our project is also reliable. So this is again one of the very good advantage. Its uses minimize conflicts and promote compatibility. So once everybody is using the same thing, everybody is consistent with the requirement, then there will be less conflicts, right? Conflicts with the vendors, with the clients, with the PMC, with other stakeholders. So those will be minimized. Although there will be conflict, there will be difference in opinion, but this will be less as compared to if we don't use these codes and standard. Now implementing the codes and standard on safe on system, reduce inventory, ensure market ready backups, right? There will be readiness, vendors will be knowing what kind of standards are available, what kind of things they have to manufacture, what are the material requirement, how we are going to inspect it, when we are going to inspect it. So all those things will reduce the inventories, and ready-made market backups will be there. So vendors will keep on preparing their inventories also. It really helps gather knowledge and add confidence. Once we know that if we follow these codes and standards, then our project will be safe, then it will help us to build the in-house confidence, right? We can gather the knowledge, we keep on reading these standards, codes, specifications, so that we know what others are doing, how things has to be done. So this will add our knowledge and confidence. Helps avoid reinventing. We don't have to reinvent. Suppose there is a new client who wants to put up a plant, then they don't have to reinvent anything. They just have to follow the codes and standard, and they will be immediately aligned with the existing clients. So this is best things which we can get out of these codes. So this was all about differences and advantages of code and standard. So in the end, you will be having this video link where this discussion is also involved, is added into the article, or you can say the video. And in the end, there is again a quiz which will be having a lot of questions related to code and standard. You can click over this and this will be starting. So there will be 10 minutes to complete this quiz, and in the end you can put up your comments also. If you want to provide your feedback, or you feel something is missing in the article, we can add that thing also. So thank you very much for watching this video where we covered the codes, standards, specifications and differences between these, and we had a lot of quizzes and video in the end. So thank you very much for watching